Yeah, good morning all. Today we'll discuss about the functions. I'll be going through these topics very quickly. Functions plays very important role in modular programming. Suppose if you are given a very complex program, your complex program can be divided into number of submodules. So in order to integrate all submodules, the functions plays very important role. The function are nothing but the small programs which are written separately from the main program, which are used to perform a specified task. So the modular programming can be achieved by making of this. In order to do this one, the C++ supports the two types of functions. The first one is nothing but standard functions. The first one is standard functions. Second one is nothing but user-defined function. These standard functions are also called as library functions or built-in functions. So these functions are part of the compiler itself. So you don't require to write a code for these functions. You need to know how to make use of these library functions for your application. The second type of function is nothing but user-defined functions. So depending upon the requirement, the programmer can able to write the function for its applications. We'll discuss these one by one. The general syntax for the user-defined function goes like this. The first field is nothing but the return type. The user-defined function or library function can also return certain values. Okay, what type of values the function is going to return will be specified by using this field. Okay, return type specified whether the function is returning a integer data, float or double, whether it is going to return a character array or something else. And we have a second field is nothing but a function name. Any valid name can be given. In most of the cases, we are going to use the meaningful name for this function name. And we have inside this bracket, we have arguments. The function can able to take certain values from the calling program so that those values are called by a name arguments. Then within this function body, you can able to write the set of statements so required for the carrying out the specified task. At the end of this statement, at the end of this function body, we have a return statement. So this return statement is compulsory whenever you specify the return type over there. So this return statement is going to return the value to the calling program. The type of the value to be returned should match with the return type. Now let us see the difference between arguments and as well the parameters. So the arguments and parameters are nothing but the values which are specified either at the calling statement or in the function definition itself. The parameter which are specified within the function header are called as an actual parameters. And variables which are used in the function definitions are called as formal parameters. We look into these two actual parameters and the formal parameter through certain examples. Before that, let's see how the functions can be classified depending upon the return types and as well as the arguments. So you can able to write a functions with no arguments and no return value. Mean that simply we can able to invoke a functions without any arguments, and also the function will not return any values. The second way is the function can able to accept the arguments and it does not return any values. The third type is the function can be invoked with certain arguments and also the function can able to return a values. And fourth type is the function can be written with no arguments, but the function is going to return a values. So means that we can able to write a program where the function can able to take an argument and also it does not return any value, and also it takes the argument and no return value, and so on. This is a one example, simple example, which is used to find the factorial of a number, say n here in this case. Before using any functions, before using any function call statement, it is must in C++ to define the function prototype. This function prototype is being used by the compiler to know what kind of function, what is the function is going to be invoked, and also what is the return type, and what kind of arguments the function is going to take, and also how many number of arguments the function is going to receive. This information needs to be informed to the compiler. Okay, so in order to invoke a correct function. So this function prototype is going to give the following information to the compiler. First one is return type, and second one is nothing but arguments and as well as their types. Okay. So in the main program, what I am doing is I am going to invoke this factorial function with an arguments. If you look at this function, f is equal to fact of fn of n. So this function, this is a function call statement which is going to invoke a function fact fn with the value n, where n is nothing but an integer. Say for example, if the value entered for the n is nothing but 5, so that you are going to invoke a fact n function with the value 5. So whenever this function call is encountered by the compiler, the program execution transferred to the user defined function, so called fact fn. The value, this is the argument which you are passing it to the function. This argument as a value 5, this 5 is copied into the formal parameter num, so that the num value, the variable num will hold the value 5. So now this is the piece of code which is calculating or computing the factorial of a number 5. So I'm going to use the variable fact here. So initially it is assigned to the 1, and I'm going to find the factorial of a number by using the for loop. So that factorial of 5 is nothing but 5 into 4 into 3 into 2 into 1. This I'm calculating it, and this for loop is going to take care of this looping. And once the this test expression is evaluated as false, means that whenever the I value goes beyond 5, that means when it becomes 6, so this condition is evaluated as false and it come out of this for loop. Okay, so that the last statement in this function is nothing but return statement. So this is going to return the value fact. The value in this variable fact is nothing but 120. So this is returned and it is assigned to the variable f. Okay, so finally this cout object is going to display the value of f, that is 120, on the user screen. So this is how we can able to invoke a user defined function and also this explains how you can able to define the prototype for the user defined function. So next is functions parameter passing. So what are the methods which are available in C++ or which is supported by the C++ in order to pass the parameter to the function? There are two methods by which the user can able to pass a parameter to the function. First one is nothing but a pass by value. This is also called as call by value. In case of pass by value, so the function does not change the content of the argument or the variables in the calling function, mean that there is no way how for the function to manipulate directly on the values which is which belongs to the calling program. Next, we have a call by reference. In certain applications, we want to let the functions to directly manipulate the values which belong to the calling program. So this is done by passing the reference of such variables to the function. So this, by using a pass by reference, instead of passing the value, the address of the variable is passed, so that the statement which belong to the function can able to manipulate the original values belongs to the calling program. It is an example for pass by value. It is a simple program which is used to swap the two integers. This is my main program. If you look at this prototype statement, the return type is nothing but void, and it is having a two arguments. So they are type integer n and m. Okay. In the main program, I have a variable a and b of type integer. The initial values of a and b are nothing but 5 and as well as 7. I'm going to invoke a function swap, okay, with the arguments a and b. When I invoke the function, so the function calls this swap, user defined function swap. What exactly happens means, whenever this particular function is invoked, the values in a and b copied into the parameters x and y. In this case, the x value becomes 5 and y value becomes 7. So that a value copied into the x and b value copied into the y. If you are going to manipulate the content of x and y in the sense that you are going to manipulate the local variable values x and y, mean that you don't have any control over the variables a and b belongs to the calling program. So here in this case, I am going to swap the variables values x and y so that finally I am going to display those values in this case by using this statement. So in this case, x becomes 7 after the swapping and y becomes 5. When you come back and display the a and b value, still a holds the 5 and b holds the 7. Okay, means that the calling program, for this particular calling program, we are passing the values, passing the arguments by values. Okay, so that the called program does not have any control over the variables which belongs to the calling program. So this is an example for pass by values. In certain applications, we want to let the functions to operate on the original value. For that, we are going to use the pass by reference method. Instead of passing the values, we are going to pass the references. That is nothing but the address of the variables. The same examples I am using here. If you look at the function prototype, the function prototype like this int and n and int and m, two arguments are here. Wherever you are using a ampersand symbol, it is understood that so the argument is nothing but an address of type integers. Here, instead of passing the values, we are going to pass the argument value. Say for example, when you declare the statement when int a is equal to 5 and b is equal to 7, it is encountered by the compiler. The compiler is going to allocate the memory for a variable a and b. So the values 5 and 7 will be stored. Every memory location will have an address 5000 and say for example 5002. For example, I have taken the 5 is stored at 5000 and 7 is stored at 5007. So whenever I use the statement function call statement here, in this case, the compiler is going to pass the address of A and B as per the prototype here. So that when I say here swap int x and swap int and y, in the sense that the address 5000, 5002 are copied into the x and y, in the sense that the x and y hold these x and y are nothing but the symbolic name for the memory location 5000 and as well the 5002. So now here I have a statement. I am going to swap the values of these. When I do the swapping here, in this case, what exactly happens here, so that the variable x and y are going to manipulate the content of 5000 and 5002, so that the integer values get swapped in this case 5 and 7. This does not happen in the previous case because the previous case uses the pass by values. So when I display here, okay, so that I'll get an x value as 7 and y value as 7. When I come back to the main program and after swapping, if I display the a and b value here, so now the a value becomes 7 and b value is equal to 5. Okay, so that by using the pass by reference, our function can able to directly act upon the variables which belongs to the calling program. So next, this is an example for function returning a values. This is the function prototype. Say for example, I am going to find the largest among the two integer number. So we are going to pass the two values by pass by value method. It is going to return the integer type. So I have a function, a call statement here, c is equal to max of a comma b. Mean that, say for example, if a is equal to 25 and b is equal to 36, if you entered like this, so that 25 and 36 is passed to the variable here, and here 25 is there in the A and B in the C. Even though I am using the same variable A and B in the function, it doesn't mean that A and B are the same, but actually A and B are local to this function max, and these A and B are local to this main program. Okay, so they are entirely different variables. Okay. So now, if I'm going to return the maximum of these two numbers, if a greater than b, if the expression is evaluated as true, so that I supposed to return a value. But in this case, it is false since b value is equal to 36. So that I'm going to return the value 36. This 36 is copied in the variable a, and this will be displayed by using this cout object. So next is passing arrays to a function. In some applications, what I want is I wanted to let the user-defined function to access all the elements of the arrays. So this is the function prototype for passing the arrays. Passing the arrays can also be done this way, or you can also use pointers to pass the arrays to the functions. Okay. So hint, and if you are using these square brackets, and it indicates that you are going to pass an arrays to the function, and the second argument is nothing but integer type. I am going to pass the size of the array to the function in this case. Okay. So next I am going to read the values for the arrays. Okay, size of my array is nothing but 5. I am going to read the 5 elements. Say for example, if you enter the values, say 12, 13, 14, 15, and 16. I entered these values. These values are stored in the arrays, array of 0, 1, 2, 3, 4, and so on like this. So next, what I am doing is I am going to display the array elements before invoking the function in increment arrays. Okay, so that when I display it on the user screen, you can able to see the values 12, 13, 14, 15, and 16. In the next part of the code, I'm going to invoke a function where my function is going to manipulate these array values. So this is the function call statement. So whenever I invoke this, okay, the control will come to this, so that I am passing the whole array into this function. The size will be 5 in this case. So what I am doing is plus n of I, mean that this statement is going to increment the ith element in this arrays. Okay, ith element, the array. We know that the original array will have the value 12, 13, 14, 15, and 16. Yeah. 16, so that initially I is equal to 0 means n of I is pointing to this element, plus n of I means the first element becomes 14. So second element the first element becomes 13, second one 14, 15, 16, and 17. So this in the I have only two statement in this user defined function. My aim is to how I can able to pass an array to the function, and how my elements of the array can be manipulated. That I wanted to demonstrate. When I come back here, I am going to display the arrays values. When I am going to display the array values, so I'll get an array values like this 13, 14, 15, and 16. When you pass the array to the function, so that the functions directly act upon the original elements of that particular arrays. Next is how we are able to pass structures to the functions. Just like any other variable, structure variables can also be passed to the function. So here the structure variable can also be passed either by pass by reference method or pass by value method. So let us consider this structure. This structure, I am going to process the student information. So the name of the student, the branch of the student, and also his marks. Okay. I have a user defined function here. One is nothing but a read function. The second one is nothing but the show function. Okay. The main function of the read function is that it is used to read the values for the members of the structure of type student. And the show function is used to display the members of the student structure student of student. So here the read is going to return the structure of type student, but the show function is going to take the structure of type student student of type structure as an argument. So this is my main program. I am going to declare the array of structure here. I created a 25 structures in this case to make the most I can able to process 25 student information. And I am giving the option to the user, okay, how many student information so he would like to process. Say for example, say 5, means that I wanted to process 5 student informations. I am going to read the information of all the 5 students by using this for loop by invoking the function read. Okay, so for student informations, I am going to read it by invoking the functions read. When I invoke this function student of j is equal to read, we know that in the function prototype, the return type is nothing but the structure. Okay, so that structure is going to become the jth structure, jth element in the student of type structure. So read, when I invoke the functions read, I am coming over here and I'm going to create a structure. I'm placing the name here and branch of the student and also his marks. Okay. Finally, the structure S is returned back and it is stored in the. It is going to become the jth structure in the student stud, the variable student variable stud. Okay. So like this, I'm going to read the information for the 5 students and all will be stored at stud of 0 and 1, 2, 3 and 4. Okay, so by using these subscripts, it is possible for you to access the desired student information. Student of 0 means you are going to access the first student information. Mean the student of 1 is having a information about the second student and so on here. Finally, by using this for loop, I am going to display the information of the student. So here I am going to invoke the function show by with the argument student of j. Mean that if j is equal to 0 means the structure which is having the information about the first student is passed to the show. This show function is going to display the members of that structure. So that the student of 0 is copied into the S. I'm going, if you say S dot name is, the name will be displayed, the branch of the student will be displayed and its marks will be displayed. So this is how I can able to pass the structure to the function and also how I can able to return the structure from the function to the calling program. So next concept, one of the hoops concept is nothing but the function overloading. Okay. So in case of C++, a single function name can be used to handle different number and different types of arguments. So this is the ability to take more. Say for example, if I declare the function as an fact, I can able to make the same name fact for performing the different function. We'll see these through the example in the coming slides. The behavior depends upon the types of the data used in the operation. Mean that if you are going to use the same name for more than one functions, okay, so the question arises how the compiler is going to differentiate the correct function. This all depends upon the type return type and as well as the number of arguments and also their types. Let us look at the example here. I have a function, the sum. So I'm using the sum for performing the two different function in this case. If you look at the first function float type here, the name of the function is sum, the return type is nothing but float, and it is going to take the two arguments of type float itself. The second function name is also a float. The second function name is also a num. The return type is nothing but integer, and it is going to take the two arguments of type integer. Okay, so depending upon the type of the argument, the compiler is going to invoke the correct function. Let us look at these two functions belongs to the main program here. I have a statement sum 25, 25 in this case. Okay, so I mean that whenever this particular function is encountered by the compiler is going to look at the number of arguments and as well their types. So now the number of argument is 2, but in both the functions we have two arguments in this case, and compiler next is going to identify what are their types. So here both are integer type. The compiler will look for the function with the two integer arguments here in this case. So in this case, the second function is having a two arguments, but both of their type is nothing but integer. So that in this case, the compiler is going to invoke a function, the sum function, which has a return type integer, and also their arguments types are integer. So that this function will be returned. This function is going to find the sum of these two integer number, and it will be returned, and that value will be displayed on the user screen. In the second example, second statement, I have a sum 2.5 and 3.6. Still, this statement also has two arguments. Okay, their type is nothing but float in this case. The compiler is going to look for the matching function in this case. So the compiler going to find this function 1 is going to be the correct match for this function calling statement. So that this is going to invoke a function where it takes two floating point parameters. Okay, so this particular function will be invoked. In this case, you are going to find the sum of these two floating point number, and the value will be returned, and it will be displayed in the main program, displayed on the user screen by the this cout objects. So this is how I can able to overload the functions. Mean that same name can be used for more than one functions, where their return types and as well as the number of arguments and also their the argument type should be different. So next is nothing but recursive functions. So in certain application, what I want is I wanted to let my function, my user defined function, to call the same function and again till certain condition met, till for certain number of times. For that, we are going to use the recursive function, which is being supported by the C++. So the recursion is the property that when a called function calls themselves. Okay, it is useful for many tasks like sorting and calculating the factorial of a number and so on like that. Let us look at this example, how exactly this recursive function works. So here I have a function factorial. It is a user defined functions. I am going to use this factorial as a recursive function for that. Inside that factorial functions, I have a function. So the function, I have a function statement. I have a statement. The statement will be like this: factorial of n equals to n into factorial of n minus 1. You have to invoke the statement for all values of n, and n should be greater than 0 here. Okay, say for example, initially I'm going to invoke a function factorial with the value 5. So that when I call this, okay, I'm going to find this, okay, 5 into factorial of 4. Again, I'm going to invoke the same factorial function with this condition, and by passing the n minus value, I'm going to pass the decremented value to that. Mean that you are going to invoke the factorial function with the value 4. So that again, you are going to call the factorial function, so that in that case when you enter into the factorial function with the value 4, so actually that time the function is going to calculate this value 4, that is the power n value is 4 now, and into factorial of 3, n minus 1, it is 3. Now 4 minus 1 means 3. Again you are going to invoke the factorial function. Again, whenever third iteration occurs, you are multiplying the 3 with the return value of factorial function with an argument 2 now. And similarly, where in the fourth time you are going to multiply the password value 2 and you are invoking the function factorial with the value 1 here. Okay, then finally you are going to invoke the function. Again you are multiplying and invoking the factorial function with the 0. Okay, whenever the n value becomes 0, that particular function is going to return the value 1 here. Okay, this function call is going to return the value 1 here. In this case it becomes 1, 1 into 1 it becomes 1. This is being returned to the previous function call statement. Now 1 is returned, you are multiplying 2 with 1 and you will get a value 2. This value 2 is returned to the previous the function call statement, that is 2. So 3 into 2, now 6 you will get it. This 6 value is returned to this. Okay, so that you will get 6. Next 6 into 4, that is nothing but 24. The 24 is returned to this function. Okay, next 5 into 24, that is nothing but 120. 120 is returned to the called program here. Okay, this is how recursive function works. The same is implemented here in this case. Okay, this is the function prototype, recursive function prototype here. Okay, the return type is long and it's going to take a one argument, one parameter of type long. Okay, so I'm going to read a number, I'm going to pass. Say for example, in this case the number is 5, you are entering it. Okay, you are going to invoke a function factorial with the number 5. Let's see how. Okay, so the working of this function is explained in the previous slide. You are entering it this function with the value 5 here. Since a is not equals to 0, so that you are coming here, so that initially 5 into factorial of a minus 4. Okay, you are going to invoke the same function. It is not 0. Okay, so that you are coming here, so that what you are doing it, you are going to multiply the 4 with 3, 3 with 2, next 2 with 1 and 1 with 0. When it is going to return the 1 value, so that 1 is returned, the 2 is returned, 6 is returned and 24 is returned, and finally this is going to return the value 120 to the called program. So this is going to return the values to this called program. Okay, so this is how exactly the recursive function works. So next is one more concept which is being supported by the C++ is nothing but functions with the default arguments. Okay, default argument is an argument to a function, so that a programmer is not required to specify. You don't require to specify these values. When the programmer is not specifying in these values in the calling statement, so that the compiler is going to take the default argument values. Okay, these default argument values supposed to be specified within the function prototype. You need to specify which are the values you are going to make as a default. They are supposed to be specified in the function prototype declaration. So whenever you are making a call to a function without specifying an argument, so that your compiler is going automatically assign these values to the parameter. Say for example, if you look at this one, I have one function prototype statement here. The name of the function is nothing but amount. Okay, I have a principal, interest, the duration, and I have a rate of interest. Suppose if the rate of interest is not changed, so that you can able to invoke the function amount with only principal and as well as the duration, so that by default the compiler is going to assume the default value as an 0.15. Say for example, if you invoke a function like this, amount may be say 10,000, and the number of duration, say for example 25 months, if you write this calling statement like this, so that whenever the amount function is invoked, the third argument value is going to be 0.15 only. At any point of time, suppose if you feel that the interest need to be changed, then the same can be done by passing the third value. Say for example, instead of 0.15, if the rate of interest is nothing but 0.75, you can specify it. Now this new value is going to override the default value, that is nothing but 0.15. So here the default argument should always be specified from left to right in the same order in the function float type. Let us look at this example here. I have a function float type here. I am going to find the sum of some values over there. I have a 4 arguments here. In this case, I am going to make a third and fourth argument as a default arguments over there. Okay. The default values are the word 6 and as well the 7. Okay. So I am going to read the 4 integer values. Okay. Say for example, I have a 10, 20, 30 and 40. I enter the 10, 20, 30, 40 for A, B, C, D respectively. Okay. Now I have a function called sum A comma B. What exactly happens here? The function sum is invoked here. In this case, the compiler look for the matching the functions in that particular file here. But here we are not going to use the function overloading. We have only one function here in this case. What exactly happen means the compiler is going to invoke the function sum with the value A is 10 and B is 20, but 2 more arguments are missing. In this case, the compiler is going to take the default value, that is 6 and as well the 10. Okay. So now we are going to find the sum of 10, 26 and 10, and that value will be displayed and you are coming back here. So this is how the compiler is going to take the default argument values. Say for example, if you are going to invoke the same function with 4 arguments like this. In that case, what exactly happens means, so A, B, the entered values of A, B are nothing but 10 and 20, they are passed, and C and D we are going to pass here. The C value will be 30. In this case, the default value 6 is overridden here, and the D is nothing but 40, so that 40 is taken here, so that the default value is again being ignored by the compiler. In this case, for the second function call statement, the function is invoked with the value 10, 20, 30 and 40. So the sum of these values are computed and those are displayed here. So this is how we can able to make. And one of the things you're supposed to return here, say for example, always the default argument should be from right to left. Okay, only trailing argument should be made default. Say for example, if you make int 20 followed by int and so on, like this is invalid. Okay, always you have to make the arguments from this direction, that is from right to left only. So next is nothing but inline functions. Okay, say before looking into this, we have studied about the user defined function. What exactly happens in the user defined function means, say for example, this is the main program. Okay, I am going to define the user defined function, say for example factorial somewhere here. Okay, so I have a function call statement factorial somewhere in the main programmer. What exactly happens whenever this particular statement is encountered by the compiler means, so you are going to call the program, you are going to invoke the function factorial. This factorial is somewhere located in the memory. Say for example, this factorial may be stored somewhere in the 5000. For example, I have taken the address of this factorial function start from 5000 onwards here. Okay, what exactly happens here? So that the compiler is going to execute the statements which are stored starting from 5000 onwards here. At the end of this, we have a return statement, or by default return statement is also present in the user defined function, so that the function will be finally return back to the main program. That is nothing but the calling from. This is how exactly happens in case of the user defined function. So one of the drawback in case of this kind of function is that, okay, whenever you are going to invoke a function, the compiler is need to remember the return address of the program. Okay, say for example, if the function call statement stored at 7000, okay, so that if the next statement after the function call statement may be located at 7002, for example, okay, it may be located at 7002. After executing all the statement which belongs to this particular function, say factorial, you need to come back to the main program and execute the instruction which is stored at 7002 only. Okay, how the compiler is going to remember this address? For that, compiler is going to make the stack. Whenever it is going to execute a function call statement, the compiler is going to store the address of this next statement onto the stack, so that after storing the return address onto the stack, the compiler is going to execute the instructions or a statement which is stored starting from 5000 onwards. Whenever the return occurs, whenever there is a return occurs, what the compiler will do means it is going to retrieve the return address which was saved onto the stack and start executing the instruction which is stored starting from the 7002 onwards. So mean that in order to do all this, okay, some amount of memory is being used by the compiler, because you need to store the return address onto the stack. Stack is nothing but the part of the memory. In addition to this, in order to do this, so some amount of time is execution time also. There is an overload in the execution time. Mean that execution time is also little bit increased in this case. So in order to overcome this problem, we are going to make another kind of function that is called as an inline function. How exactly the inline function works means, say this is your program, this is your main program, and you have a function here. Okay, the name of the function is fun here, so that whenever you are going to invoke a function in the main program, say fun, what exactly happens in this case means that your main program will be expanded. At the point of function call, the whole code belongs to this F1 will be inserted, so that your main program is expanded. Okay, so that you don't require to save the return address onto the stack, and you don't require to retrieve the return address onto the stack, because you can able to see the sequence of statement which of this fun belongs to the main program once the invoke function is encountered by the compiler itself. Okay. One of the drawback of this inline function is that, okay, so that at the point of function call statement, your the whole code is inserted here. Okay, due to this, suppose if you are going to invoke the same function several times, so that so much of memory space will be being occupied by this main program. So that is the mean that the memory is the disadvantage in case of the inline functions. Okay, but the time is not a critical parameter in this case. When I feel that, okay, memory is a critical parameter, so in that case you can able to go with this method. Okay, so whenever you feel that, okay, the time is critical parameter, so in that case you can able to make the inline function. Okay, so it is a function that is expanded inline when it is invoked or when it is called. Okay, as I told that the compiler is going to replaces the function call with the corresponding function code. Okay, all inline function must be defined before they are called. It is similar to the functions of user defined function here. So it is easy to make a function as an inline, okay, just by makes the keyword that is nothing but an inline. Okay, so this is the syntax for defining the inline function. Inline, it is nothing but the keyword. So return type, what type of value the function is returned, and function name followed by the number of arguments, then function body. So in this, actually this inline function is being used for only small functions, not for the large. Suppose if the user defined function, if you want to make the user defined function inline and the user defined function is too large, in that case the function will not behave like a inline function. Instead that it behaves like a ordinary function only. Okay, suppose if the function body contains only the few statement, least number of statement, then only it is preferred to use the inline function. So this is an example for demonstrating the inline function. I have the inline functions here, which is defined here. The multiplication MUL is a function name here. It is defined as an inline here, and the return type is float, and it is going to take a 3 arguments here. And also same thing is done for the double types also, double dot type, inline, double division. You are going to divide the divide number, and it is going to take the 2 arguments here. So okay, float A 12.345, float B 9.82, mul A comma B. What exactly happens here? This particular statement will be inserted at this point. You are not going to execute this inline function. See that the whole inline function is inserted somewhere here. You are going to find the product of these two, and similarly you are going to divide the values P and as well the Q in this case. So this is how I can able to use the inline function for my application. So next is passing array of structures to the function. Okay, program to find the student who scored highest marks in the examination. So this is the problem statement. In this case, what I'm doing is I'm going to pass this structure to the functions, and there I'm going to find the required one. Okay, so this is the structure definition. Again, I have a name, department, and as well the floating point marks, and I have a read function. This we already discussed in the previous example, and the show function, which is used for displaying the information about the student. Okay, so now this is the statement, function prototype statement. This is going to identify the student who has scored the highest marks here. Okay, I'm going to pass an array of structure to this function high marks, and another argument is nothing but integer. It may be the number of structure which you are going to pass. As usual, I declared the structure variable, and I'm going to read the student information. Say for example, n is equal to 5 student informations I wanted to read. I wanted to find which student has scored highest marks. Okay, for this. Next, what I'm doing is I'm going to pass the array of structure to the student. Okay, first argument is student of type structure. Okay, so that this is passed to the high marks, and also the size. Size in this case is nothing but 5. 5 is passed over there. When I pass here, actually I am coming to this function here. Okay, so that the whole structure is copied into this. Okay, so that the 5 is copied into this. Say for example, the first student name is nothing but A. First student name is nothing but say A, and the second argument is nothing but say department, say branch is E, and say marks, percentage of marks, say 91%, and so on. First student, and similarly second student C, D, E. Okay, so that same I am going to use the same branch here, and 72, 83, 65, and 70. Okay, these are the marks. Okay, say instead of this I am going to use, say for example, somewhere here 93 here for instead of the first array, the first student score. It's instead of largest, I'm going to make the student score 93 in this case. Okay, so next I am starting with the first student whose index value is nothing but 0. So I am assuming that, okay, so that the variable big is going to hold the marks of the student, first student. I assume that, okay, first student marks is nothing but itself big. Otherwise, I am going to change the big values. Okay, if for int j is equal to 0, j less than sz, j plus plus. You can able to start with the j is equal to 1 also. It doesn't matter. Okay, if s of j dot marks greater than big. Okay, since j is equal to 0 here, s of j marks is also 91 and big mass is also 91. Okay, so that is not true. Okay, so that you are not going to change these values. Okay, then you are coming here. Then your j plus value is equal to 1. Okay, now you are pointing to 72 here. Okay, s of j is 72. 72 is greater than 91. Okay, so that you are going to check whether the first student, second student marks is greater than this or not. 72 is nothing but is not greater than 91. So that this you are skipping this if body. You are coming back here and so on. You are moving to the 93 here. So now the student mass is 93. 93 is greater than 91. In this case, you are going to assign the index of the student who has highest mass to the variable index. Okay, so now the index value is nothing but in this case that is nothing but 2. So the 2 is assigned here. The highest mass is nothing but 93. 93 is assigned here. Okay, earlier it was 91. Now it is overwritten by this 93. Okay. Similarly, you are going to look for compare the 4 student marks here. So whether 65 is greater than 65 is greater than big or 93 or not. Now the big value is 93. So this statement, the condition is evaluated as false. Okay, this if body will not be executed. Finally, you are going the 70. Still, it is false. Okay, so now this condition is evaluated false for the 6th iteration. So you are coming out. So you are going to return the index value here in this case. Okay, so what is the index value? The 2. Okay, the index value is 2. So I mean that is understood that the third student is going to have a highest marks. Okay, so now you are coming back here so that the index value of the student who has highest value, highest marks is stored in the ID value. Okay, so that you are going to display that student value by passing that particular structure to the user defined function show student of ID. That is nothing but you are going to pass this to here. The second student details, that is nothing but name is C, branch is nothing but EC, and scored marks is nothing but 93 is displayed on the screen by using this statement. Okay, so this is how I can able to pass the array of structure to the function. Okay, next is nothing but a pointers. Whenever you are going to deal with the data structures, okay, so data structure cannot be implemented without pointers. Even if you are trying to implement it, but still it is possible, but it is very, very complex and it is very tedious job to implement the data structure without pointers. Pointers is a variable which stores the memory address of some other variable. It is just like similar to the other variables, but it is going to hold the address of some other variables. We'll see here how exactly the pointers can be used for our application. The pointer is nothing but an example of derived data types, okay, similar to the arrays only. Okay, as I told, it contains the addresses of memory location instead of their values. So before using a pointers in your program, the pointers supposed to be initialized so that these initialized pointers are used to access and manipulate the data stored in the memory locations. So these are the uses of pointers. You can able to access the array elements by using the pointers, and it is also possible for you to pass arguments to the functions, okay, by using the pointers. And you can able to pass arrays and as well as strings, and this is one of the most important thing is that the pointers are very much useful for memory management dynamically. It supports dynamic memory management because during the run times we require to create the required amount of memory space for the application, so that can be done by using the pointers. And also during the runtime, it is also possible for you to release the memory to the operating system. Okay, so pointers are the efficient tool for manipulating the data structure, such as structures, linked list. You will be studying all these things, binary trees. So pointers reduce the length and complexity of a program. Okay, and as I told, without pointer also we can able to implement the data structure, but your length of the program will keep increasing it. But if you are using a pointers, it makes the programmer job easy. Okay, and also increases the speed of execution, and use of a pointer array to a character string results in saving the data storage space in the memory. Mean that you can able to save certain amount of memory. Okay, if you are using a pointers for holding the array of character strings. let us consider this statement to understand this pointer concept. I'm not going to teach you the pointers in depth. Okay, just I'm going to give the introduction about the pointers. Let us consider this. I have a three statement C++ statement. Int num is equal to 70, sum is equal to 50, average equal to 60. What exactly happens in this whenever these statements are encountered, the compiler means the compiler is going to allocate the certain space for these variables. Say for example, the num, the value 70 stored in the memory 70, the symbolic name of the memory is nothing but num. Okay, this is the alias name for this memory location. The address of that memory location is nothing but 1000. Okay, I am assuming these values, but assigning the address, allocating the memory locations to the desired variables is the job of the operating system. For example, I am assuming it 1000 here, and sum is a integer type. Okay, the value 50 is stored in the memory location. The name of this location is nothing but sum, and their address is 102. And similarly, the average is the value 60 is stored in the 1004. Okay, so your system finds the location for each integer as I told and put them in the respective memory locations. Okay, next let us look at the another operator, that is nothing but we are using the ampersand symbol, that is nothing but the address of operator here. Okay, you can find the application of this address of operator. Okay, so while writing the program, let's see how exactly the address of operator works. Okay, so I have a simple program with for the previous example itself, I have a num 70, sum 50, and average is equal to 50, and it is nothing but address of, and stands for address of. Address of. Okay, then refers to address of. Okay, now if you write and num means that address of num. Okay, so num is nothing but the symbolic name for the memory locations. According to our examples, the num is the symbolic name for the data 70, which is stored at 1000. Okay, so now if you write and num means address of num, so that this particular statement is going to display 100 instead of 70. Okay, similarly address of sum means nothing but, okay, you will get a 1002 on the user screen, and average means address of average is nothing but 1004 will be displayed. Okay, so this is how you can able to find the address of the memory locations. Okay, let us see here how you can declare the and initialize the pointers here. Okay, the general syntax for declaring the pointers is like this. This is only the declaration statement. Initialization will be done later. So data type, what type of data this data type is going to specify the type of the data to be stored in the memory location. But this data type does not tell you the type of the address. Always the address, computer memory address is always integer. Computer memory is always integer, address is always a integer, but this data type is going to specify what kind of values is stored in those locations. The star, we have asterisk symbol, this tells that specified variable is nothing but a pointer variable. Okay, so pt name needs a memory location, and pt name finds the variable of type here. Okay. Say for example, I have int star int ptr, char star ptr, and c star ptr. Mean that I am declaring the pointer variable which is used to point to the memory location where integer value is stored. That is the meaning of this. So here char star char ptr means it is not an character point. This is nothing but chptr is nothing but a pointer variable. It holds the address of the memory location where the character data type is stored. Similarly, complex data type the address of the complex data type is stored in the cptr. Okay. So mean that int PTR in the sense that it is used to hold the address of the memory location where the integer data type is stored. Similarly, CHPTR is used to store the address of the memory location where character data by char data type is stored, and so on like that. So we are going to use this asterisk symbol. It is nothing but a value at address. The meaning of star is nothing but value at address operator. So when the operator star is placed before the pointer variable in an expression on the RHS sub equal sign, the pointer returns the value of the variable. We'll see later how that can be done. Okay. So any operation that is performed on the dereference pointer may affect the value of the variable it points to. So I mean that it is going to directly operate on the pointed values. Okay, so these are the points you're supposed to remember before using the pointers in your program. Before a pointer is initialized, it should not be used. Before using the pointer, you need to initialize the pointer. Initializing the pointer in the sense what, which value you are going to manipulate or which value you are going to operate. The value of that, the address of that particular value is supposed to be stored in the pointer variable. We must ensure that the pointer variables always point to the corresponding data type. Say for example, you declared the pointer to pointing to the integer type, and if you are trying to put the address of the character type, it is not allowed. Okay, there is a mismatch with the initialization. Assigning an absolute address to a pointer variable is provided. Say for example, if you feel that you have a data in the memory location 5000, if you are trying to assign these absolute values directly to the pointer, it is not allowed. Okay, so through the variables only you are supposed to initialize the pointers. So let us consider here variable num 70 char a, and average is nothing but 60.75, 60.25. They are stored in the memory this way. So average is 60.25. These are nothing but the address of those memory locations here. Let us consider these three statements. What exactly happens? Int star num PTR. Okay, so that num PTR is a variable of type pointer. Okay, it is created to hold the address of the integer data types. Okay, mean that the space for this num PTR is allocated in the memory. The num PTR is nothing but the symbolic name for this location, the whose address, for example, is 5000. Okay, similarly for CHPTR, character pointer. Okay, sorry, this is not the sum PTR. Just consider this one as an CHPTR. Okay, char PTR, the whose address is 5000, and average PTR, it's a the address is nothing but 5000. If you look at this here, these memory locations are not yet initialized, mean that the programmer yet to initialize the values of these pointers. I'm going to demonstrate how you are going to access the values, num value, character value, and average value by using these pointers. Now, these statements are going to do the initialization here. Okay, in the previous slides, we have declared the pointers and as well the basic data types also, and also we have seen what are their addresses. Now, I'm going to initialize the pointers here. Num PTR is equal to and num. Okay, when I do this and num, what is the address of num? If you look at the previous slides here, and num, address of num is nothing but 1000. When I say num PTR is equal to and num here, mean that the 5000 location will have the value 1000. If you look at this one, you will get an 1000. Similarly, char PTR is equal to and ch. Address of ch is nothing but 1002, according to our assumption in the previous slide. So that 1002 is stored over there. And similarly, for this statement, last statement, 5004 is going to hold the address of average, that is nothing but 1003. Mean that the value of num, char, and as well as the average are stored in the 5000, 5002, and 5004 respectively. Now let us look at this one. I have a statement like this. If I write star num PTR, okay, star num PTR. Okay, so star is nothing but value at. The meaning of star is nothing but asterisk symbol is nothing but value at. Num PTR. What is the num PTR value? Num PTR is nothing but 1000. Okay, num PTR is nothing but 1000. So mean that the value at 1000, value at 1000 is nothing but 70. When you write the statement star num PTR means you are trying to access the value 70. Okay, it is nothing but the value of variable num here. Okay, you are accessing the variable num through the pointer. Okay, similarly chptr, okay, star ptr, value at chptr, that is nothing but 1002. Value at 1002 is nothing but a value. Okay, that is nothing but the symbolic name for that location is nothing but ch, whose value is nothing but a. Means that star chptr refers to the character a. Similarly, star float PTR refers to 60.25. Star float PTR is nothing but sorry, this is not float average PTR. Okay, this is nothing but AVG, average PTR. Okay, average PTR is nothing but 1003. Value at 1003 is nothing but 60.25. Okay, so this is how you can able to use pointer to access the values which are stored in the some other variables. Okay, so these are the some of the simple program to demonstrate int variable 1 11, int variable 2 11, int star PTR. I created an pointer variable here. Now I am going to initialize the PTR pointer variable. PTR is equal to and variable 1. Mean that the address of this 11 is stored over there. Address of the memory location where 11 is stored is initialized to the PTR. If I say star PTR means my statement is going to display 11, means that you are going to access the variable 1 value through the pointer. Okay, so in this statement you are going to initialize the and variable 2. Okay, so that this statement is trying to access the value 22 which is stored in the variable 2. Okay, so that you will get 22 here. Okay, so that this is the output of the program 11 and 22. So what are the operation you can able to perform on the pointers? Okay, the first operation, pointer variables can be used in expressions. Okay, and you are able to use the pointer variable in the expressions. See, y is equal to star ptr1 in p2, mean that two values which are being pointed by the pointers can be multiplied. Okay, next we have next one is say sum is equal to sum plus star ptr1, mean that this can be used to access the value that can be used in the sum summation statement, and you can able to do z is equal to 5 star minus star p2 and so on like that. Okay, so this is how I can able to use pointers for different in different operations. Okay, shorthand operators may also be used with pointers. Okay, say we have a shorthand operators, nothing but increment and decrement operator, and also some assignment operators where these are the valid statement. If I say p1 plus plus plus, in the sense that actually this is going to increment the address. Okay, you are going to decrement the address of the pointer by using the decrement operator. So you can also use the pointers to compare the things, okay, using the relational operator. In certain application, I wanted to know why pointer values are same or not. I can able to use in the relational expression like this. Whether p1 greater than p2 means whether the address in the pointer p1 greater than p2 another address or not. Whether the one address is equivalent to the another address, means that whether I wanted to know whether both the pointers are pointing to the same locations or not, and these are used for whether they are pointing to the different locations or not. And these are the operation which cannot be performed by on the pointers. Okay, pointers are not used in the division and multiplication. Pointers cannot be divided and cannot be multiplied. P1 divided by address cannot be divided. Okay, sometimes when you divide one address by the another address, you may get a address which may not belong to the computer memory system. And P1 and P2, when you multiply the one address with another address, it may result a product. Okay, that address may not belongs to may not be supported by the system. But pointer multiplication and divisions are not possible. So two pointers cannot be added and two pointers cannot be added together. Okay, this is illegal statement here. So these are the operations we can able to perform on the operator. We can able to perform on the pointers. You're supposed to remember here. These are the most important points. Pointers cannot be multiplied and divided, and pointers cannot be added over there. But for all the other operations, you can able to use the pointers. So pointers and arrays, by using the pointers, it is possible for you to access the elements of the arrays. We have studied in the array topics, so the different elements belong to the arrays can be accessed by making of the index variable, the subscripts. Okay, so that by using the subscripts, it is possible for you to choose the statement, elements which belong to the different location of that array. By using the pointer, it is possible for you to access the element which belongs to the arrays. We are going to use the base address of the array. By using this base address, it is possible for you to manipulate the pointers so that you can able to access the element which belongs to the specified arrays. Let's look at this example. I have pointer variable, integer pointer variable, and I have variable sum and j here, and I have a integer array. The name of the integer array is nothing but x. Okay, so that is here. I initialize the values 5, 9, 6, 3, 7 over there. Okay, so now I have p is equal to x here. Okay, so whenever you are using a variable x, in the sense that it always refers to the address of the beginning address of that array, so that you don't require to use the and x here. Even if you are using it, the compiler won't return shows the errors over there. P is equal to x. So without ampersand symbol also, you can able to assign the array address to the pointers here. Or x of 0 is nothing but the first element in the array. The address of that first element is nothing but the base address of that array. So that address can also be assigned to the pointer variable p. So that p is equal to and of x of 0. This way also you can able to do here. So now say for example, x of 0 is nothing but, say for example, 5, 9, 6, 3, 7. Say for example, the address of the first element is 7000. This is going to be 7002, 4, 6 and 8 and so on like that. Okay, so that now your p is holding this value. Now your p is holding this value. Okay, I'm going to find the sum of these elements. See out. Okay, I'm going to display all the elements simultaneously. I'm going to find the sum of those numbers. Sum plus star p plus. Okay, so as I said, when you say p is equal to x, in the sense that, so your p value becomes a 7000. Okay, p is equal to x means nothing but base address of the array. Okay, so that, so sum is equal to sum plus p. Initially some value is 0. 5 is added to 0, it is stored in the variable p. Now I am incrementing the loop control variable value p plus plus. I wanted to access the second element in the array. In order to access the second element in the array, my pointer should point to these 7002 locations. To do that one, I am going to increment the arrays here, so that now my p is incremented towards the value 7002. These are the p values. If you look at, after the first iteration, my p value becomes 002. When I come back and executing this, okay, now I am going to access the value 9 here. 5 was already pointed and 9 you are pointing it. Again p plus plus means now the p value becomes 7004. Okay, so that you are pointing to this and so on. This way you can able to access all the elements of the array by using this pointer. Finally, you are going to display that value and you are coming out of this. Okay, so this is how you can able to use the pointer to access the arrays. Pointers and arrays and functions. So this is an example which is used to pass the arrays by using the pointer to the function. Void. Okay, this is the program which is used to sort the elements in the ascending order. Okay, void b sort, I mean that bubble sort. I'm going to use the bubble sort here. Okay, this is the name of the function. Int star. Okay, mean that pointers you are going to pass and as well as the size of that number you are going to pass. Next you have a void order star, mean that you are going to invoke one more function from this b sort. Okay, So you are invoking this order function from the bubble sort function. Okay, so that where you are going to swap the elements or not swapping the element depending upon the elements. Okay, depending upon the values of those elements. Okay, the size of my array is nothing but 8 in this case. So that 8 is assigned to the constant variable size here. Okay, I created a pointer variable. The sum have here, and also the array I declared and as well the initialized it here. I have an 8 elements here: 15, 9, 65, 3, 7, 12, 85, and 0, 1 here. And I'm going to assign the base address of the array to the pointer variable p here. Okay, so that before calling the invoking the sorting function, I'm going to display the all the elements. Okay, star p plus 5. Okay, so this statement, if you look at this statement, okay, we compare this statement with the previous statement. Here, I can also access the different elements, okay, of the array by using the pointer by using this method star p plus I. I know that the p is holding the base address of the array. P is holding the base address of the array. That is nothing but say 15. 15, the location where the 15 is stored is nothing but the base location. Say address is 5000. The 5000 is stored in the pointer variable p plus I, initial value of 50. I don't want to manipulate the p value. I wanted to keep the base address constant. By using the subscripts, I want to access the different element belongs to the array. That can also be done. Okay, just by changing the I value, it is possible for you to pointing to the different element by using this pointer. P plus 5 means you are going to find the element which is located at p plus I in the array. Okay, so this is how I can able to. Okay, so all the elements will be displayed here. B sort x and size. You are going to pass the parameter to the function here x. That is nothing but the array, and size you are going to pass. Okay, when you are going to write x here, actually according to the data type, so you are going to pass the address here. Okay, that address will be copied to the actual parameter which is specified in the function definition here. If you see here, the address x is copied into the star ptr here. Okay, what is that address? 5000 in this case, and your size is nothing but 8 is copied over there. Okay, you know the how bubble sort algorithm works. By using this bubble sort, you are going to sort the elements. I'm not going to explain this bubble chart in detail. Just say, for example, if you have given element 25, 36, and 05 and 02 and so on like this, first you are going to compare these two elements. If the first element is greater than the second element, if you are doing the ascending order, okay, if you are going to sort for ascending in the elements, okay, in the ascending order, if you are doing it, if I am comparing it, when I compare these two, these 25 and 36 already in the sorted form, I don't want to swap these two elements. I am leaving as it is. Next, I am going to compare the second element with the third element. 36 is greater than 05. So that what I will do means I am going to swap these two elements so that my array will look after the third iteration like this and 02 like this. Next, I am going to compare these two so that swapping is required so that after the third iteration I'll get 05, 02 and 36 and so on like that. Now one sorting is over. So that is the largest number. 36 among the 4 element is occupied in the correct position. Similarly, you have to do this iteration for another n-1 times here. Okay, compare 25.06 and 02 here. Okay, depending upon the magnitude of the number, you have to swap the elements. So that you are going to do it here. You are going to invoke the another function order. Okay, where you are going to pass the address of the first element, say 25 and 36 to this function. Address of 25 according to our example, say 5002 here. Okay, now you are going to check whether the first number is less than the number 2 or not. If the first number 1 is less than the number 2, so 25 less than the number 2 means you are going to swap the numbers. Otherwise, you don't require to swap the number here. This will be done and you are coming back here. If you look at this here, you are going to access the elements of the array in the B sort and as well as the harder function here. Okay, mean that since you are using a pointer, so that all the statements which are written in the function order and as well as the B sort are directly operating on the original array element, so that the original array will be sorted at the end of the program. So the pointers can also be used to access the structures. Okay, similar to the arrays, we can able to use the pointers for accessing the structure. How you are going to create the structure array means it is the same way only. Okay, it's only thing is that you need to make the asterisk symbol. If you use the asterisk symbol along with the the variable name, so that that becomes the variable which is used to pointing to the structure. Okay, define specified structure here. So in order to access the structure members, we are going to make the operator that is called as an point to operator. Structure PTR variable point to operator. So that is nothing but member name. But actually we were discussing about the operator which is used to access the members earlier was using the dot operator. Okay, by using the dot operator, it is possible for you to access it. But using the point to operator, you can able to use the pointer to access the members of the structures. Quickly, I'll go through it. I created a structure here which is used to store the date. Okay, I want to store the day, month, and as well the year. Okay, those three members are declared here. Okay, this is the another member function. These two are the member functions which are used to display the structure information. So using the pointers over there. Okay, so I created a structure D1. Okay, D1. And another structure pointer I created it here. Okay, so that one more statement I have here. Okay, so that I am dynamically creating the structure. Okay, the address of the structure is stored in the DP2. Okay, so here you are going to allocate the memory for the date of type structure. Okay, using the new operator. This is the dynamic memory allocation operator. This is going to return the address of the structure. That address of this structure is automatically initialized to the DP2. You don't require to initialize DP2 once again here. It is already initialized in this statement here. Okay. Next, I have a statement read and P1. And D1, where D1 is nothing but the structure here. Okay, you are going to pass the structure date. Okay, so address of the structure to the read function, where I am going to read the member functions, value for the member function. When I come here, okay, when I come here, okay, so that that address, just a minute. That D1 structure address is pointing to copied into the PTR variable. I am going to read the value for day, month, and year. Okay, so that I am going to access these variables through this pointer. Okay, so say for example, I entered a date as 22. Yes, 22 is stored into the day by using PTR pointing to day. Say month is, say for example, 09. Yes, 09 is stored into this by using this statement, and year is stored in the year. So that is by using this PTR point to year. Say if the entered year is nothing but 2010, it is stored over there. So that the structure D1 will have the following values. So 22 for day, 09 for month, and 2010 for the years. Okay, so next after that, I'm going to read DP2. I'm going to invoke the function DP2. I don't require to make use of the hand simple here, because DP2 itself a pointer. You're going to pass a DP2 to that. Okay, when you are coming here, you are going to read the value for DP2. So your DP2 structure, second structure, is going to have a values like this. Suppose if I enter 10 and 03 and 2021, this will be stored over there. DP1 is equal to and D1. Okay, DP1 is the pointer, so that you are going to assign the structure address of the D1 to the DP1. Okay, so that you are going to pass the pointer DP1 to the show functions, where you are going to display all the values. Okay, CTR points to DP day, so that you'll get 22 and this is going to display 09, and PTR points to year is going to display 2010. Okay, and I'm going to invoke the same function with the just a minute. Second function I'm going to invoke with the DP2. When I invoke it, coming to the show function, so that the DP2 address is copied to the PTR, so that second time when you invoke it, actually you are going to display 10, 03 and 2021 here. Okay, so this is how I can able to make use of the pointers in my applications. Okay, today I'm going to complete the session here, and overview of the C++ is almost completed over. From next class onwards, we are going to look at the data structure. We'll start the actual data structure from the next class onwards. If don't leave, just I'll take the attendance. Thank you all for attending the classes. From Monday onwards, we'll start in with the data structure with introductions. Okay, thank you all. And I heard that F section student could not able to access the videos. Yesterday I given one more link. Is that link is working? Anyone verified with? Nikhil? Is that link, video link is working?